Hello and welcome to a screencast about the point-slope form of a line. A line with a slope m, or equivalently the average rate of change, as we've been calling it a lot recently, m, that passes through the point x naught, y naught, and it's what these little subscripts here mean, or you could say x0, y0, whatever, but just know that this is just any point on your graph. Has the equation y equals y naught plus m times x minus x naught. All right, now this may look a little bit different to you than formulas you've seen before. If you were to scoot this y0 over, that might look a little bit more familiar. Oops, x0 there. Okay, so maybe that helps, but we just like to have it in the y equals form up here. Okay. All right, so there's basically two things that you need for this. So you need your slope, so that's what goes in here is your m, and then you need a point on the graph, and like I said, that's any point at all. So that's your x0 here, or your x naught, and your y naught. Okay. Now the one thing that I see confuses students the most with this is this negative sign in there. So don't forget to put that in there. So you're basically, I don't want to say changing the sign of your x value because you're just shoving that x value in there, but that negative in there does change the sign. Okay, beautiful. So find the equation of the linear function in point-slope form shown in the figure below. Okay, so here's my figure. So let's write down our point-slope form again. So y equals y naught plus m times x minus x naught. All right, so like I said before, we need two things. So we need to know what the slope is, and then we need to pick a point, any point, on this line. Okay, there's lots of points on here. There's actually infinitely many of them. Now, how many nice ones are there? I don't know. I definitely see a nice one right here, so I'm going to pick that point. So I'm going to pick my x0, y0 as -2, 4. All right, m, and sorry my dot's kind of wacky there, I just realized. M, let's see, so in order to find our slope, or our average rate of change, we need to know another point. So it looks like there's another nice point over here. So then to figure out my m, I want to do my change of y over my change of x. So my other point I'm using is 4, 2, just so I don't forget. I probably should have written them up here, but that's okay. Or we can just drop down and go over. Yeah, let's do that instead. All right, so let's go down. So our change of y then is going to be 2 divided by our change of x. Oh, well, let's make the y, or the change of y negative since I went down. Then my change of x is going to be 6. So it looks like my slope is -1/3. And if you chose different points or did it a little bit differently than I just did there, then hopefully you would end up with the same answer. All right, so now go ahead and plug things back into my formula then. So y equals my y naught then, I'm using this particular one, so that's my y value there of 4, plus, although it's going to be a minus, so I'm just going to do -1/3 times, I'll just do plus a negative just to keep it consistent, and then x minus my x value, and that's a -2. Okay, this is a little bit messy for me, so I'm going to clean this up just a little bit. So 4 minus 1/3 x plus 2. And you can just stop right there. So you might be asking, well, if I picked a different point, my line's going to look different. And the answer is yes, it will. But if you were to distribute everything out, combine all your like terms and all that fun stuff, you'd actually end up with the same answer. Okay, now let's go the other direction. So this time I gave us the equation and I want us to graph it. Okay, so this one kind of takes a little bit of maneuvering to it. So now you've got to be able to read this particular function and figure out what it's giving you. Okay, so if we remember our formula, so it was y naught plus m times x minus x naught. So then you could just kind of compare pieces. All right, so I'm looking at this and I think, okay, so I need my slope and I need my point, my x naught and my y naught. Okay, so my slope is what's sitting here in front of the parentheses, so that's 1.5. And then my x naught, so my x naught's what's being subtracted from the x. but I have something being added to the x. Just like we saw in that last example, then that means that my x value must be negative. But my y value is what's being added to the front, so in this case that's going to be a positive 2. Okay, so the signs can get a little bit wacky sometimes, I know, so just do the best that you can with this. And before I start graphing, I like to do my slope as rise over run, so I would prefer to see this decimal as a fraction, so I'm going to write that as 3/2 instead. Okay, so let me go ahead and plot my point, -3, 2. So that'll be here. I'm going to try to be fairly accurate, so hopefully that's the case. And then, uh-oh, I'm already in trouble. I've got to be able to go up 3 and over 2. So I think that'll put me right up here at the top. So I'm at 2. I need to go up 3, which is going to put me at 5, and then over 2, which I think is going to put me like, we'll just say right here. But I can also go down 3 and left 2. I think that might be a little bit better. So I'm going to go down 3, so that's going to take me down here to -3, and then over 2, which is going to take me to -5. So that's here. Ooh, okay, those look like they'll form a line. So now we just need to sort of make this as accurate as possible. Oh boy. Okay, pretend like that's actually straight and it actually went through all the points. But you get the gist of it. So again, the important part is being able to look at this line, pick off the important values, and then translate them into the graph. All right, have a good one.